Hi friends, welcome to my channel. So this lecture is being done in three parts. Part 1, we will see one of the classical problem of process synchronization, producer and consumer. And in part 2, I do about readers and writers problem. And in part 3, I will do dining philosopher concept. Very interesting problems will be asking by GATE examination, but sure 2 marks questions are carried over semaphores, especially deadlock and semaphore with the classical problems. Semaphore deadlock is a compulsory question, no doubt. If it missed, then you will be asked based on these classical process synchronization problems. So let us begin producer and consumer problem. Before entering into producer consumer problem, let me give a small brief. What are the main things are involved in this? There is a concept of a buffer. Buffer is nothing but a free space where you can store your items. Observe, this is a buffer or a bucket where items can be stored initially, and those items are generated by there is a process by name called producer. What is a producer duty? Producer duty is he has to check buffer is empty or not. If a buffer is empty, observe carefully. If a buffer is empty, then then start produce the item, start produce the item, then store to buffer, store to buffer. This is the producer side. That means initially buffer is empty. You're also looking the figure. There is no item is there. Now producer produced item 1, then producer produced item 2, then producer produced item 3, then item 4, then item 5, then item 6. Bucket is filled. If bucket is not empty, if a bucket is not empty, if this condition is failed, if this condition is failed, these two lines won't be executed. You have to what? Wait till at least one slot available, till at least one empty slot available, empty slot available. Now you may get a doubt that who will clear these items from the buffer or bucket. There is a one more process by name called consumer. What consumer checks, are there items or not? Are there items or not? Items or not in bucket or buffer. That means he has to check whether bucket is empty or filled. Has to check condition bucket is empty. If a bucket is empty, if yes, then he can't consume. He has to wait until producer produce the items. If a bucket has items, then what he will do? He will consume item, then he will remove from the bucket. He will remove from bucket. So according to the order, there are 6 elements are there. Then understand that bucket is not empty. Item 1 is consumed and item 1 is removed. Then item 2 is consumed, item 2 is removed, and 3 and 4 and 5 and 6. This is about consumer process. So as soon as a one slot has come, then producer is busy. He will cross check. Do I have any empty one slot? Yes. Then immediately item 7 will be produced. Then again he will think of that. Can I able to produce? No. Because again this condition is going to be not true. Then he has to wait. And the consumer also, after consuming all items, he need to check whether the bucket is empty or not. If a bucket contains no elements, then you're supposed to be under what? Waiting. So this is how you imagine a situation. Those are the points I have mentioned here. So, in order to implement producer-consumer problem in a well way, so that you never see a concept of race conditions and inconsistency results, take some semaphores. One is that producer and consumer cannot come into the buffer at a time. Producer and consumer cannot come to access the buffer at a time. This should not be. This is the first condition. Race condition concept is multiple hands are in the bucket. Then the process synchronization concept is only one hand should be in the bucket. Then there should be a control semaphore you're supposed to use. There should be a control semaphore. This is the first semaphore between producer process and consumer process to establish a proper synchronization. And second one, producer has to check is the bucket empty or not? Are there how many empty slots? So empty slots are designated by n. So n elements you can produce. So here another semaphore that is E. E is for what? Checking empty. This is for empty semaphore. And third one is that full. This semaphore will tell you whether the particular bucket is filled or not. If it is completely filled, the producer cannot able to produce it unless consumer consumes and removes the element. So F stands for filled semaphore. How many slots are filled? Is it completely filled or half filled? So these are the three semaphores you're supposed to use. One is a control semaphore between producer and consumer, and the other one empty semaphore with n value. The other one filled semaphore is equal to 0, because whenever you talk about the starting of the producer and consumer process, initially bucket is empty. That's why filled slots are 0, empty slots are 5 or n. And one more analogy is whenever producer is producing, he has to take care of control semaphore by reducing S successfully. S is equal to 1. Yes, now I am entering into bucket. Before entering into bucket, here bucket is nothing but a what? Shared resource. My dear friend, don't forget that. Here bucket is nothing but a what? Shared resource, because it consists of very precious elements into that. The bucket is a shared resource which is monitored by there is a semaphore called S. The semaphore S is managing this. Semaphore S. So 1, 0, because it is an initial value of 1, that means only one process can enter into critical section. These are all assumptions only. Then after that, producer, P stands for producer process. After that, producer has to cross check is bucket empty or not. That's why there is another semaphore. E is talking about N. I'm taking 5 slots. This bucket has 5 slots. Slot 1 and slot 2, slot 3, slot 4, and slot 5. So where you can place 5 items into that. Item 1, item 2, 3, and item 4, and item 5. So 5 slots. You can take any number of slots. I don't mind, because I am discussing about unbounded buffer. But here, if I am restricting E is equal to 5, which indicates that bounded buffer. Bounded buffer means it maximum allow you to fill only 5 items or slots. So wait says, now you need to check how many empty slots are there. So you should see that, am I able to decrement E value successfully or not? Yes, there is a 5. E stands for 5. So I reduce by 1 because weight function always gives -1. Then it becomes 4. That means weight is a successful down in this case because you're able to decremented it. That's it. Once you decremented it, now you're in a critical section. In this, you can add an element. Now I am added an element here. Yes, item 1 is filled. While leaving, I supposed to say that because this is supposed to give a signal. Then what I am doing that signal of yes. Before giving signal of yes, you need to say that filled slots are initially 0. They say that one filled slot because one item is filled. Then what you need to do? I'm incrementing the value. Observe, my dear friends, carefully. Incrementing the value means signal. Decrementing the value means wait. So what I need to do is I need to give signal of f. That's it. F becomes 1. So mutual exclusion is done excellently because process synchronization is supposed to offer mutual exclusion, progress, and bounded waiting. Let us say that producer is repeating one more time. Again, this f is nothing but what 0 to 1. It is s is nothing but what already s made 0. Now 0 becomes what 1 here. That's it. Again, I am going back. This time the value of s is 1. So 1 becomes 0 successfully. And weight of E, yes, successful. Weight is nothing but -1. This becomes 3. You entering a critical section and produce one more item. Then filled slots are how many? 2. How will you say signal? Signal means +1, 2. Then while leaving semaphore, we will say that 0 to 1. Again, this guy is going back. Again, I will say that 1 becomes 0. Empty slots are there or not? Yes. Validation I am checking. And 3 becomes 2. And the 2 becomes 3. Filled slots are 3. Empty slots are 2. Again, he is going. Then wait. It becomes 1. Then filled slots are 4. See, parallelly decrementing and incrementing. Empty slots are decrementing. Filled slots are incrementing. Then after that, once more time 0. Yes, it becomes 5. After that, one more time we try to start. If 1 becomes 0, I don't mind. But 0 is going to be what? Unsuccessful down. When you say unsuccessful down, I can't enter into critical section. Even though the first semaphore allowed me to the next line, but not possible because this is restricting you because the empty slots becomes 0. Filled slots becomes 5, which indicates that the buffer is completely filled. This is about producer. Let us see the consumer. What is a consumer? Consumer says that S is equal to 1 and filled slots already 5 and empty slots becomes 0. Now he has to first to see the control variable. Wait, yes, am I? Yes, 1 becomes 0 because already producer produced. Already producer produced 1, 2, 3, 4, 5 slots. 1, 2, 3, 4, 5. And now producer is under waiting. He can't produce it. He is under waiting because second line is not allowing. Then what happened? Wait of yes. Yes, successful. Now you need to cross check. Are there any filled slots are there or not? F becomes how much? 5. Then 5 becomes 4 because wait is going to do -1. Then he can enter into critical section. He is going here and consume and remove the element. That's it. You got one empty slot here. Then while leaving, you're supposed to say that increase the empty slot. That means increase the empty slot. So increase the empty slot is nothing but you need to go which function? Signal function. So signal of E. E earlier how much? 0 empty slots. Now 0 becomes 1. In this case, filled will be decremented, empty will be incremented. So again, I need to go for control variable access to me. Then 0 becomes 1. Again, consumer go back. Again, same story. 1 becomes 0. Weight F. Weight F means -1. This becomes 3. He enter into the critical section. He remove the slot and 2 empty slots. So signal of empty. Then again 0 becomes 1. So semaphore is a control variable which is signaled once again. It's going back. Again wait successful. This wait becomes 2. This signal becomes 3. That means 3 empty slots, 2 filled slots. So you will come to this. 3 is removed, 3 empty slots. Again he go back. 4 is removed, 4 empty slots. Again he go back. 5 removed, 5 empty slots. Again he go back. Weight S I can agree, but weight F F value becomes how much after some time? 0. 0 means it is not allow you to decrement. So you will be aware waiting. Excellent pseudocode given for producer and consumer by the author. That's it. Even Semaphore is allowing you to access, but a next line is restricting you. So who has to wake up? Producer has to wake up. Again, producer chance will come. He will say that weight of yes, so 1 becomes 0. Then he will say that what? Weight of EF, weight of, because now the scene becomes reverse. The filled slots are 0, empty slots are 5. Then weight of E, is it possible or not? That means overflow condition is taken care by the producer. Underflow condition is taken care by the consumer. Again, I am repeating. Overflow condition is taken care by the producer by using a weight E, and underflow condition is taken care by the consumer using weight F. Yes, there are 5 empty slots. 5 becomes 4. He will come here and produce item 1. Then when you produce item 1, immediately raise F value. F is initially 0. There are no filled slots. Now there is a filled slot. And while going back, you wake up the semaphore control. 0 becomes 1. Again chance go. This is how the producer and consumer problems are real world classic examples. You can test by giving us a preemptions. I don't mind anywhere to anywhere. It is not allow the process, multiple process to access this buffer simultaneously. You want more to test? I will test process and consumer. Control semaphore 1. Empty slots is equal to 3. Filled slots are 0. Line number 1. This guy is saying, producer is saying wait yes. 1 becomes 0. There is a preemption came. Consumer side piece of code is checking weight of yes. Is it possible? No, not possible, because already somebody is there. Somebody is there. That means 1 becomes 0. So it is not possible. This is one solid example. And another example, let us say consumer begins using same value s is equal to 1. This time empty slots are 0, filled slots are 3. Now in this case, this guy started initiation weight of yes. 1 becomes 0. There is a preemption. His piece of code is weight of yes. It is not possible. Therefore, you are going to be under waiting. Excellent piece of code. So what is the code? Let us see. Producer produces data. Consumer consumes data. Assume there is a buffer that can store elements of n slots. Number of empty slots n. Number of filled slots 0 initially. Producer produces items as long as empty slots are available. And producer produces only one item at a time. Consumer consumes the items. Consumer consumes the items as long as there are items. That means underflow checking condition taken care by consumer. Overflow is taken care by producer. Consumer consumes only one at a time. Two producers can produce at the same time, but cannot insert or append into the buffer at the same time. Two consumers can consume at the same time, but cannot take or consume from array or buffer at the same time. Producer and consumer cannot do at a time. The buffer or in a critical section. So this is the piece of code. First one is wait E. See that a small change is done in this algorithm. Why? I will tell you. Wait E, overflow. This is for what? Overflow checking. After filling E slots, initially 5, then initially 4, then initially 3, initially 2, then 1, then becomes 0. You can't go to next level. Then control semaphore, signal S, signal F. Consumer side, you need to check underflow condition first. Then after that, control semaphore, then take the item, and while going, signal S and signal E. Why it is mentioned wait E first and wait F? In the previous, I have not written like that. I have taken initially wait S and wait E. What is the difference? Let me explain. This is the piece of code now. So producer coming with weight E. Why not it is starting with the S? Let us say empty slots is equal to 5, filled slots is equal to 0, semaphore is equal to 1. Producer is starting. If I say weight S and I want to say that weight E, and consumer side I'm starting with weight S and I'm coming with weight F, what will happen if I use a regular approach like this? So first line is initiated by producer, weight S, 1 becomes 0. Then you see that. Then there is a preemption. The preemption is saying that weight of S, it is not possible because already somebody is holding it. Okay? Somebody is holding it. So he is going to be under waiting. I agree. Come to a new approach. First producer is doing weight S 1 0, then weight E. Clear? Weight E means empty slots will be decreased 5. Again going back, signal E, signal F and signal S. Producer is going. This time weight S and empty 4, empty 3, empty 2, empty 1. How many times he got chance? 5 times got chance. 5 items are produced. Whenever items are produced, filled items are going to be increased. Signal of F, and while leaving, signal of S. That is the piece of code is here. Signal of S and signal of F. So if you change it, there may be a chance of what? Deadlock. There may be a change of deadlock. Improper use of semaphores leads to deadlock only. Okay, so producer produced 5 items. Then empty slots becomes 0, filled slots becomes first 0, then 1, then 2, then 3, then 4, then 5. That's it. Sixth time he is trying. Sixth time producer is trying whether your algorithm will stop you or not. Let us see. Wait, yes. Yes. Because while you are releasing the semaphore, it becomes 1. So 1 becomes 0. Wait, is it possible? Not at all. Second line is holding you. But your control semaphore allowed, but your empty semaphore not allowed. Who has to wake up? Consumer has to wake up. Let us see the consumer side. Wait S, when I say wait S, because first line is done, second line is done, third line is trying. Wait S, it's not possible. It's not possible because somebody already decremented the value. He can't go back unless second, third, fourth, and fifth lines are executed by him. Unless third and fourth and fifth lines are executed by him, he can't wake up on his own. So consumer is trying to enter, but it is unsuccessful because somebody is already making it down. That's why, first of all, you need to cross-check this underflow and overflow. That's why E and F semaphores are first is given. That means before you want to go to the control section, or critical section, first consumer and producer supposed to check weight E, is it unsuccessful or not? Here also weight F is successful or not. In the earlier cases, 5 times producer iterated, then this becomes 3, 2, 1 and 0. And filled slots becomes automatically 0, 1, 2, 3 and 4 and 5. Then in this case, he is trying sixth time. Weight of E, it is not possible because it becomes a 0. 0 can be -1. You will be suspended. So unless this is successful, you can't go for the second line. That's it. So you are not allowing to critical section because second line is unsuccessful to you. Who can wake up? Consumer. Let us see consumer got a grant or not. F value. He is checking weight of F. What is weight of F? Is positive value. Then 5 becomes 4. Then weight of S. What is weight of S? Weight of S. S is not used so for anybody because he still is under waiting this case. Because first line is unsuccessful, you can't go for second line. Weight of S 1 becomes 0. He will enter into the critical section, and while going, he will say that what? According to our algorithm, While going, it is a signal of yes and signal of E. Signal of yes and signal of E. Now, so what is the signal of E? Signal of yes, 0 becomes 1. Signal of E. E is how much? What is it right now? 0. Then 0 becomes 1. Now he got the chance. Because weight value is not 0. It is a 1. 1 becomes 0. Now the semaphore can be allowed. That's why your piece of code is supposed to be like this. It's supposed to be like this only. Weight of E checking overflow. Weight of F checking underflow. If both are satisfied, control semaphores there and here. While going, control semaphore signal, control semaphore signal, and increment F value, decrement, increment E value, and increment F value. So signal of E, empty slots are going to be incremented. Signal of F, filled slots are going to be incremented. This is what is a piece of code, especially for producer and consumer. So filled slots are mainly talking for consumer side. Empty slots are mainly talking by consumer side. So when slots are consumed, F value will be, filled slots will be decremented and empty slots will be incremented. While producing the items, empty slots will be decremented and filled slots are going to be incremented. This is how producer consumer can do it. But sometime if there is an unbounded buffer, if there is a unbounded buffer means empty slots are going to be n. There is no checking care of overflow condition. No checking of overflow condition because it is having indefinite space overflow condition from producer side. From producer side, he will keep on produce. But see that underflow supposed to be done. Consumer has to check underflow. So dear friends, what is the final piece of code? Producer and consumer. First you need to check underflow and he needs to check overflow and you need to go for signal of yes, weight of yes. If other side he is also supposed to do weight of yes, weight of yes. Then both can access your shared buffer signal of signal of yes, signal of F, while going signal of yes, signal of E. Signal of yes, signal of E. That means filled slots are decremented. This is for decremented of filled slots. Whenever filled slots are decremented, empty slots will be incremented. Empty slots are incremented. This is at consumer side. And weight E means empty slots are decremented because he is producing item. Empty slots are decremented and signal of F, filled slots are incremented. That's it. So excellent piece of code. That's why it is called as a classical process synchronization problem.